Welcome back to day 2 of notes on ellipses. Now that we know the standard form for an ellipse and its orientation based on the standard form and how to plot the endpoints in the major and the minor and the focal points, we're going to take some of that information given to us in a different form and actually write the equations of those. So if you have not done the first assignment for ellipses, the homework assignment from the textbook, I would highly recommend you go back and you do that first before you proceed with this video. So let's take a look at this example. We have focal points at plus or minus 3 in this case, and I think it's really helpful if you've got a piece of graph paper or a coordinate system close by where you can plot these points. Plus or minus 3, 0, so I've got a focal point there and a focal point there, and so I know that this ellipse is going to be longer in the horizontal direction. Endpoints of the major axis are plus or minus 5, 0. And if you remember, a squared is equal to b squared plus c squared, and a is the distance from the center to the endpoint of the major axis, b is the distance from the center to the endpoint of the minor axis, and c is the distance from the center to the focal point. So based on this information, what we know, and this is where graphing is helpful, is we know that we have a center at 0, 0. We know that a squared is equal to 25 because a is 5. We know that c squared is equal to 9 because c is equal to 3. And from this, we can find b squared, which would be 25 minus 9, is equal to 16. So we can write the equation of our ellipse as x minus 0, if you like, squared over 25 plus y minus 0 squared over 16 is equal to 1. Let's try another one similar to that. So we know that we have focal points, plural is foci, at 0 plus or minus 4. So 1, 2, 3, 4, there is one focal point. 1, 2, 3, 4, there's another focal point. So we know that this is going to be an ellipse that's longer in the vertical direction. Endpoints of the major axis at plus or minus 7. So those are 4, 5, 6, 7. So there, 5, 6, 7 there. And so what do we know? We know we have a center at 0, 0. We know that a squared is equal to 49. We know that c squared is equal to 16. And we know that b squared plus c squared is equal to 49. So we know that b squared has to be equal to 33. So the equation of our ellipse is going to be x minus 0 quantity squared over 33 because it's longer in the y direction, so y term gets the larger denominator. Y minus 0 squared over 49 is equal to 1. All right, let's try a few more like this. The information in C is that the focal points are at 0 plus or minus 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we know that this is an ellipse that's longer in the vertical direction. The major axis length is 26. So that's from one endpoint to the other endpoint of the ellipse in the longer direction. So we know that from the center, we're going to have to go up and down 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're going to be way out here and way out here. So let's write down what we know. We know that the center is at 0, 0. We know that a squared is equal to 13 squared. which is equal to 169. We know that c squared is equal to 25, and we can find b squared because we know that b squared plus c squared is equal to a squared, so b squared has to be equal to 144. So the equation of our ellipse is x minus 0 quantity squared. As always, you can drop that 0 if you like, divided by divided by b squared, 144, because it's longer in the vertical direction, y minus 0 squared over 169 is equal to 1. All right, for letter D, we have endpoints of the major axis as plus or minus 4, 0. So 1, 2, 3, 4. 1, 2, 3, 4. So we know that this ellipse is longer in the horizontal direction. Endpoints of the minor axis, plus or minus 3, 0. 1, 2, 3. 1, 2, 3. And so we know we have a center at 0, 0. Our value of a squared is equal to 16. Our value of b squared is equal to 9. And c squared plus b squared, or b squared plus c squared, has to be equal to a squared. So c squared is equal to 7. So the equation of our ellipse is x minus 0 quantity squared over 16a squared, because it's longer in the horizontal direction, over plus y minus 0 squared over 9 is equal to 1. In this next problem, we're given the information about the endpoints of the major and minor axis in a slightly different form. So again, I think it's useful to have a place to graph these while you're doing these. So let's locate those points. The endpoint of one axis, -2, -3. So -2 down 3, so there's one endpoint. And -2, +7, so 2, 2, 4, 6, 2, 4, 6, 7. So we know the center is going to be halfway between those, and we'll get that center in just a minute. The endpoints of the other axis are -4, +2. So -4, +2, and 0, 2. So we can see just by looking at the points we plotted that this ellipse has a center at -2, +2. We can see that the distance from the center to one endpoint of the major axis is 1, 2, 3, 4, 5. So a is 5, so a squared is equal to 25. We can see that the distance from the center to one endpoint of the minor axis is 2. So b is 2, or b squared is equal to 4. And c squared plus b squared is equal to a squared. So c squared has to be equal to 21. Now we can write the equation of our ellipse. X plus 2 quantity squared over 4, it's longer in the vertical direction, plus y minus 2 quantity squared over 25 is equal to 1. All right, one more like that, and then we're going to go on and practice with completing this square. So the major axis endpoints are -5, +2. 1, 2, 3, 4, 5, +2. And 3, 2, 1, 2, 3, +2. So we know the center is going to be halfway between those at -1, +2. So we'll write that down, -1, +2. And the distance from the center to the endpoints of the major axis are a. So I can see that a is 4, or a squared is equal to 16. The minor axis length is 6, so that's half of that is b, so we go up 3 and down 3. So we know that b squared is equal to 9, and again, c squared plus b squared is equal to a squared, so c squared must be equal to 7. The equation of our ellipse, which is longer in the horizontal direction, is x plus 1 quantity squared over 16 plus y minus 2 quantity squared over 9 is equal to 1. All right, you will see we skipped the two problems on parametric equations. That's because of the remote learning days. If we were in a regular class, we would do those, but we're going to skip that stuff for now. So, in problem I, we have to take this general form for an ellipse and put it into standard form. I know that it's an ellipse because the coefficient of the x squared term and the y squared term are both positive but different. And so to do that, I'm going to have to complete the square. Well, if you recall, one of the things that has to be true when you complete the square is you have to make sure the leading coefficient is 1. So here's how we're going to do that. We're going to start by grouping together all the x terms and all the y terms and moving the constants over to the other side. So we're going to put the 42 over on the other side. The next thing we're going to do is we're going to divide the x terms by 3 by factoring out a 3 and get x squared minus 4x plus whatever we're going to put in to complete the square. We're going to do the same thing for y, so 5 times y squared plus 6y plus whatever we're going to put in to complete the square is equal to negative 42, and then whatever we put in to complete the square for x and for y, we're also going to have to add to the other side. So if we take what's inside parentheses here, and we go ahead with how we normally complete the square, we would have x squared minus 4x. Half of negative 4 is negative 2. When we square that, we get positive 4. Do the same thing for y. 5 times y squared plus 6y. Half of 6 is 3. Square that, we get 9. But when we add them to the other side, you need to be careful because this 3 here and this 4 here are being multiplied by each other. So we have to add 12 to that side because of that. And we have to do the same thing for the 5 and the 9 for y. So we have to add 45 to that side. So now we go ahead and we factor what's inside the parentheses. So you'll notice x squared minus 4x plus 4 factors into x minus 2 quantity squared. Leave the 3 coefficient where it was at. The y squared plus 6y plus 9 factors into y plus 3 quantity squared. Leave the 5 where it's at. And you will notice that the numbers over here on the right hand side add up to 15. So we'll put that over there. And we're almost done putting it in standard form. What we need to do is divide everything by 15 and simplify. So we will have x minus 2 quantity squared, 3 and 15 reduced, so there's a 5 in the denominator, and 5 and 15 reduce, so there's a 3 in the denominator, and 15 over 15 reduces to 1. So we now have that in standard form. I would like you to do the same thing for letter J. Pause the video, do letter J on your own, and when you're done, press play on the video and check your solution. Okay, so you start by grouping the x terms together and factoring out a 4 and grouping the y terms together. You don't have to factor anything out of the y terms because the coefficient of the y squared term is already 1. So half of negative 8 squared is negative 4. Square that, you get 16. Half of 16 is 8. Square that, you get 64. But the 16 associated with the x's gets multiplied by 4. So that needs to get added to the other side as 64. The 64 associated with the y's is not multiplied by anything, so that gets added to the right-hand side. Everything on the right-hand side adds up to 256. Factor these and then divide everything by 256 and you end up with the equation in its standard form. Now I would like you to go ahead and do the second assignment from the ellipses homework.